I spent over a month learning and building AI agents so I could explain it to you. I watched a bunch of YouTube videos, read a bunch of blogs, read a lot of documentation. There is a lot of confusion in how to build an AI agent, and most of the videos talk about no-code tools. But I wanted to build something from scratch. So in this video, I'm going to show you how to build a real estate agent. Everybody seems to be building an agent right now, but most of the tutorials out there are either too basic or too complicated. This tutorial is for somebody like me who is a staff engineer, so understands code, but also is not an AI expert, so needs some level of understanding of what is an agent, how to get started, and use some of the commonly available free tools. Because we ain't paying money yet. Let's get into it. Hello everyone, and welcome back to another tutorial with Shruti Kapoor, your favorite developer, entertainer, content creator. And in this video, I am going to simplify building an AI agent for you so that you can build your AI agent and learn how to do so with a code tool called LangGraph and use Convex. We're also going to be using OpenAI as our LLM. I'm a staff software engineer, so I understand how to write code. It is my mission to help you get into software engineering, survive in this field, and thrive in this field. So today, we're going to learn about AI agents. Now, first up, what is an AI agent? I like to think of AI agent as the librarian in a library who helps you identify which books you are interested in reading based on your preferences of reading a book. One of the main parts of an AI agent is the ability to react. React meaning reasoning and act. The AI agent can understand the response that it gave you, reason if the response was good enough, and act on that response in order to give you a better response or provide you the result based on the reasoning of the quality of the response. Now, how does that apply to the librarian case? The librarian picks a book for you, understands if the book is going to be a good one for you by either seeking input from you or understanding some other data that is present in the database of the library, such as your previous books that you've read, understands that response given back from these tools, either you or the database, and acts on it. Either gives you the book, recommends it to you, or finds another book, thereby acting as a react agent, reasoning about the result that it gave you and acting upon it. That is an agent. A key part of the agent that we briefly touched was the ability to use tools. In the case of librarian, the librarian can either look up in the internal database, which acts like a tool, or ask you, the human, which is another tool. So the ability to use tools helps an agent to perform tasks that are not part of the original LLM that it was based on. So for in our case, it would be that whatever information is not available in OpenAI's LLM, the GPT model, we can still use an external tool like a database or Google search or web search to perform those actions, which is what makes agents super powerful. Because now you're no longer dependent on the data that you were trained on. You can provide additional tools such as RAG or databases, API, or even web searches so that the agent can perform things that are not even within the LLM. Let's take a look at what we're building today. We're going to make a better way to look for real estate in Seattle. I know when we're looking for a property on websites like Zillow and Redfin, the number of filters can be so overwhelming. So I made a much easier way to look for a house by just typing in English. Here's how you can do it. Here's what I'm going to do. I'm going to say looking for a 4-bedroom house in Seattle. That's all I'm going to provide. And then I'm going to hit search. And there you go. I've got places that have at least 4 bedrooms and some places that have a little bit more than 4 bedrooms. And imagine if I have a question about this property specifically, I could say, ask a question, and this is where my real estate agent comes up. And I could ask it something like, how safe is this neighborhood? And it thinks for a while. And it's going to say, well, based on the search results, the property at this is located in this area. To assess the safety of this neighborhood, you may want to refer to crime maps. The crime map of this is 114.9 per 1,000 residents. And compared to surrounding cities, the rate of crime is higher. And here's something I can ask the agent to do as well. I can say, what are some things to do here? And it can look that up and say, there are several things to do in Seattle, especially around this area. You could visit Green Lake Park, do this, and so on. And something cool is that because I have access to Convex database, I can also generate a list of properties that look similar to a property that I clicked. That I'm looking at this property, it thinks, well, you may be interested in these other properties which are similar to the property you clicked. How did we do that, and why does it think those properties are similar? We're going to take a look in the demo. Let's get into it. Let's take a look at the architecture of the app that we're going to build. Here's the front end. App.jsx is the main entryway to our component, which then in turn calls other UI components. We're also using TanStack, router, and query to do routing for our application and for managing API calls. We're using TanStack query instead of calling API calls directly within UseEffect because we want to avoid calling an API too many times. One, because that runs out our data limits, and two, we don't want to pay too much to OpenAI because of the tokens that it can send. On the backend side, we have an Express server which calls the LLM API, and we have endpoints set up in the Express server. One of the endpoint calls the LLM API. Another one calls the Zillow API, which helps us to get data from Zillow. And then we have another endpoint, which is where we're going to create the agent. We're going to store our real estate agent there. We also have an endpoint to call our database, which is Convex for us. The reason we're using Convex is because Convex works really well for real-time data and with AI apps. Convex provides functions right out of its SDK in order to have functionalities such as vector search that can help us compare two different properties with each other to see how close they are. Vector search can be really helpful in AI applications, and we can also store embeddings within database. Overall, I think Convex is not only a great database, but also for AI apps. I find myself always reaching for Convex because most of the things that I want to do in my AI app are already provided by Convex, like creating an agent, creating an MCP server, getting vector embeddings. It's already provided by Convex. Convex has also graciously decided to sponsor this video. So shout out to Convex. I already loved using Convex before they were even sponsoring this channel, and I'm so grateful for Convex for sponsoring this channel. On the API side, we're calling a few different APIs here. We're calling Zillow API, through which we're getting data on real estate listings. We're also using LangChain and LangGraph to actually interface with OpenAI. So we're not calling OpenAI directly. And the reason is because LangChain and LangGraph provides interfaces built on top of models like OpenAI and Anthropic so that you can build the application without having to worry about the integration with a specific LLM. So tomorrow, if you want to change the LLM or change the model, it's easy to switch it out. So that is the architecture of this app. Now let's get into building the application. So once we've checked out the GitHub repo linked in the description below, let's check out the step 1 branch, and this will help us get ready for this step. After that, I just ran npm run dev, which gets my Vite server running. So now I've got Vite running on localhost 5173, which is right here. And at the same time, I'm also going to run the backend using npx tsx source api / api.js. Let's give that a run. And when you run your API, you will probably get an error similar to this, which says this file is not found, or index.js doesn't exist, or an expected token, which is totally normal because we haven't created our backend API yet. So let's go ahead and create that API file. This is going to be our Express server. So I'm going to go into my branch backup, and here you'll see that I have a source API api.js. Drag that into my source. Move. Perfect. Close my branch backups. And don't worry about any other file in this. We're going to take a look at that in a second. But the file that we're interested in is api.js. This file already does the job of parsing the property from English language sentence into JSON using Zillow API. If you're interested in how we built that, I have the video linked right here. We have done this in a previous video using a different database, but let me explain to you what's going on real quick. We have an Express endpoint called parse properties. When we click the search button, we call this parse properties endpoint. We take the requirements out of the body and get the price ending, the price starting, and the number of bedrooms. So a user will write something like looking for a 3-bedroom house in the range of 600,000 to 900,000 for sale. And once we hit that search button, we get that price ending, price starting, and number of bedrooms out of this. So let's console log to see what's going on. we're going to console log our properties requirements. So at this time, we are ready to get our API running. So let's do npx tsx source/api.js. Cool, we got our port running. And now if I hit search, awesome, I'm getting properties requirements coming back. So I've got the price ending, which was 900,000, price starting 600,000, and number of bedrooms. Great. Of course, something went wrong. Don't worry about that for now. Let's remove this. And the next step we do is we call fetch properties, which let's take a look into it, which is the function that actually calls the Zillow API, the RapidAPI. So we send it a few parameters like location. If we are looking for a location, we'll send that over. Otherwise, Seattle, Washington. Listing status, which is it for rent, for sale, or anything. So we pass that in as well, along with a default of for sale. Property type, that is going to be whether it's a house. Again, we can look that up from properties requirements. Home type or single family. Bed minimum, maximum, and the minimum and a maximum price range. This is where we pass in the options that the user sent in. We've got that fetch parameter set up, and we send that over using a fetch call to our Zillow API, which is going to be the RapidAPI endpoint. I put that RapidAPI endpoint right here in case you need to look that up. Awesome. And once we get the response back, we just send the results over back to our API endpoint, which is in parse property. And now in the parse properties function, what we do is we make sure that the property's price value lies within the starting range and the ending range. And if it does, we filter those out and send that back over to our front end using filtered response. Now that we're sending the filtered response back, let's give it a shot to see what we get back. So let's try an example search. Hit search. Okay, cool. We're starting to get properties now. So if you look at this, we had a price range of starting range of 600,000 to 900,000 with 3 bedrooms. We're getting properties within that range with 3 bedrooms or more. Perfect. So that sets up our UI so that we can integrate with our API, which is RapidAPI for Zillow. And now let's start building the agent. Because in this app, we're going to be making a lot of API requests and calling Zillow API, OpenAI, we're going to use React Query from TanStack, also called as TanStack Query, in order to fetch our APIs, cache them on the client side, and overall make it easier for us to call an API instead of using it in UseEffect. Let me walk you through the code of how we do that. Let's talk about why we need use infinite query instead of the typical use query. Here's the documentation. Rendering lists can additively load more data onto an existing set of data, or infinite scroll, fetch next page, which helps the query know how to fetch the next page and get next page from. So let's write that. So first thing, we're gonna get use infinite query from React Query. Now let's go ahead and call this hook. We're gonna call use infinite query, and it accepts a bunch of parameters. So here's the first parameter it accepts. The first one is query key, and this is the key that is required for this hook in order to refetch. Anytime this key changes, the hook is going to call the new API. For us, we only want to call the API or fetch new properties anytime our input changes, which is somebody is searching for a new requirement when our requirement has changed. So we're gonna say query key for us is gonna be search input, which is what is the user searching. The next function that is important in this is the query function. When the search changes, how should we actually fetch this? In this code, we have a function called get properties from natural language. That is going to be our query function. So I'm going to copy that over in here. Then my AI, which is I'm using augment code, is telling me that the next thing I need is get next page param. So let's add that, but not quite this yet. We're going to do something interesting here. We're going to store all the properties in a ref variable this time. And then what we're going to do is, instead of making the API, making the hook fetch the API, we're just going to loop through our storage variable and loop through that variable. So the code for that is going to look like this. So let me explain this to you, what's happening. Let's also create that ref. All data ref is use ref null. So what we're going to do is we're going to use this ref as a storage bucket. When we get properties in this function, we're actually going to store this into our all data ref. And now, instead of calling this API every time somebody clicks on show more data, we're just going to loop through our all data ref storage. And that's going to help us reduce the number of API calls we make, right? We get the total pages that are displayed so far, and we check if there is value in ref and the total number of pages is greater than the value in ref, which means we've displayed all pages, return undefined, as in there's no more pages to return. Otherwise, we're going to return pages.length. If there are no more properties, we're going to return undefined. Otherwise, we're going to return pages.length, which, because it's length, it is automatically incremented by 1. Okay, so now this use infinite query actually returns back like properties, and we're going to use those properties for our UI. So let's extract data out of it that we need. So here's what we need. We need the loading, the error state, the is error. Data is now set in properties, and that's how we're going to render properties on the page. Has next page is fetching next page. And those are some variables that we can use further down in our UI to conditionally render properties. So we had the is loading variable. We're going to use that to create a loader. And then when we hit search, it's going to actually show a little spinner. We have the is error coming from use infinite query. For that, we're going to use that to create an error component. And in order to show the properties, we're going to check if the properties exist, which is get properties dot length greater than 0. We're going to return our properties listings, which is a component we created. I'm going to provide all the properties and then map through the property to create a new component called property card. And now if I hit search, we'll see we'll get each of these property cards. Now, in order to implement pagination, this is what we have to do. Remember, we have has next page coming from use infinite query. We're just going to use has next page and say, if we have a next page, create a button called show more properties. And if we're fetching the next page, we're going to say loading more properties. I'll show this to you in action. So at the bottom, we have a new button called show more properties. If we click this, it says loading more properties because we're fetching next page. And once it's loaded more properties, it'll say show more properties. This way, we have a whole list of more properties we can fetch from without having to call the API. The magic of TanStack query. Now, we have an ability to fetch more properties and we are paginating these lists. Now let's add an ability to save a property when we like or dislike a property. We want to save these properties in our database because this is going to help us understand which properties a user likes, so we can show them more properties like that. Or we can also understand which properties a user doesn't like, so we can disable those properties. Let's try that now. Now let's add a like and dislike button so we can save a property that a user has either liked or disliked based on their preference. In order to get ready for this, let's check out the branch. In order to get ready for the step, check out the branch step 3. All right, now if I run my app, I try an example search, I hit search button. You'll notice that I've got this like and dislike properties now, which is nice. So what happens when I like and dislike property? Let me open the console and show you. Now, when I like the property, it says liked a property, and when I dislike a property, it says disliked a property. And this logic exists in property details.jsx. I'm going to copy this over. There we go. There we go. I've also gone ahead and added some fields as optional because we may not always save them in the database. I've also gone ahead and added some fields as optional like preference and nice to have. Okay, now that we have our schema, we are ready to make convex functions. Let's talk about which functions we want to make. When we like a property, we're going to save that in the database. In order to create a property in the database, I'll have to create a mutation function. Now, if you look into your convex folder, you'll notice that there are 3 files in here already, and I've already added template for adding this mutation. So let's take a look into this. If you open the property.js file, you'll see there is an insert mutation. This is the mutation we're going to use. I've already added the fields that we're going to be using. Add the logic to insert a property into convex. Let's get const. Okay, so const property is await. This is the method that we need. We need context.db.insert is the method that we need, and we need to insert that in the property table and the arguments that are being sent over. So I've got this function ctx.db.insert. I'm getting this insert function from convex, and I'm going to add into the property table and all of the arguments that I got. And it's as simple as that. And then I'm just going to return the property.id. Cool. That is good enough, but we haven't created embeddings yet. So let's go ahead and create that. Now, if you open the llm.js file, you'll notice there's a function here called generate embeddings. This is where we're going to generate embeddings. Let's talk about how do we generate embeddings. In order to generate embedding, we're going to convert a JSON into string and then send that over to OpenAI to create that string into vector. And that is the vector we're going to insert into our database along with the rest of the property data like price and stuff. Let's convert this property into string. So what I've done here is I've created a string called property text in which I'm just filling out the details of the property. So I'm going to say property in this, add property address, add with this bedrooms, with this bathrooms, this price, this home type and stuff. And now with this string, I'm going to call the OpenAI API to convert this text into embeddings. So this is what I call. I call the OpenAI endpoint /embeddings and I pass in the property text along with my OpenAI API key. And the model I'll be using is text embedding 3 small. So now I'm passing in text and the data that I get back is going to be an embedding. So I'm going to get my embeddings out of it and then I'm just going to return this embedding. Now this generate embeddings functions is going to create an embedding. We can also test this by running and then finally we're going to return the embedding. Okay, so we've generated the embeddings for as of now and now let's try inserting this in the database to see what we get back. Let's go into our property details, which is where we handle like, and this is where we're going to store that we like the property. So we're going to call the insert mutation to store that property in the database. And while we're storing this, we're also going to call the generate embeddings function that we just created in order to store the vector representation as well. So again, when we like a property, we're going to save in the database. We're going to store all of the property details along with the vector embedding of that property. At this time, I'm going to get all of the detail of the property out of it. And I'm going to insert that property. But wait, this is the property that I just clicked. I do not have embeddings for this yet. So before I insert the property, I also need to generate the embeddings. For that, I just need to call the function that I just created. So before I insert property, I'm going to call my generate embeddings endpoint. And remember, this is on the server side. And then if response is not okay, I'm going to throw an error. And if response is okay, I'm going to get the embeddings out of it. And before I insert the property, I'm going to destructure embedding out of it. And while I'm inserting the property, I'm also going to send in embeddings. And I'm also going to say if property inserted successfully, or if there was an error, I'm going to log that. Cool. And then I'm going to do the same thing for disliked a property. So remember, when we like a property, we're going to set the preference to true. But when we dislike a property, we're going to do the same exact thing, except we're going to set the preference to dislike. To false. Same exact thing. I've connected my handle like and handle dislike buttons. So now if I try an example search, let's see which of these properties do we like. Let's say that I like this property 9637 42nd Avenue Northeast Seattle. I'm going to open my console, moment of truth, like this property. Okay, it says property inserted successfully, but let's check in our database. Okay. I have a property at the top and 9637 42nd Avenue. Sweet. Now if I like another property, let's try this one, 6759 21st Avenue. Hit like. Actually, let's try dislike. Hit dislike. I dislike this property. It says dislike the property and property inserted successfully. And now if I check my database, the first option here is 6759. See, it's real time, so it updates right away. So it says 6759 21st Avenue, preference is false. Perfect. I've got, and look at this. This is where my embeddings are. This is what the embedding looks like. This is vector data format. What this embedding is going to help me is help me compare two properties with each other. So Convex actually provides a really handy function called vector search, which helps us search between properties that are saved in the database. And this is why we're saving properties in the database. So we already got an embeddings. And then what we're going to do is we're going to perform this vector search function on this table, which is the properties table for us, by embedding. And then the vector is the embedding that we have created. And we're going to filter based on which value. For us, that's going to be the price, the number of bedrooms, the number of bathrooms. So let's go ahead and create this similar properties function for us, which is going to do a vector search. An easy way for creating agents is through LangGraph. In this example, we're going to take a look at LangGraph's documentation and create a React agent, an agent that can reason and act. Let's take a look at the docs with the LangGraph in JavaScript. So in this example, it actually creates a LangGraph agent that can reason and act, called a React agent, and search the web using Tailwind Search API. This is awesome because this is exactly what we need to do. Tailwind Search is actually a web search tool that can be used to ask questions, but also it does the job of searching the web for the answer. If you scroll down to the example here, all you need to do is add your API keys and import these libraries, and this is how you create the tool. So let's copy this over, and we're going to use that to create our agent. Now I have a file here called agent.ts, and this is where I've created a real estate agent. This agent expects two items. One is the question. It's kind of like a chatbot. You're asking the agent, the real estate agent, a question, and you're asking it about the question about a property, and it gives you back the result. So we're gonna paste this code in here, and let's clean this up. All right, so let's talk about what this code does. First of all, the model we're using is OpenAI ChatGPT 4.0. The memory is going to be short-term and long-term memory provided by LangGraph, and this is why creating an agent using LangGraph is a great first step. It gives you access to create memories already. And why is memory helpful? Memory is helpful because if you're asking the agent a question, it needs to remember which property it's talking about so that you can ask it follow-up questions. So for example, you can start off with something like, hey, I'm looking for a 4-bedroom house in this and this, or you can ask it like, what is the rental area around this? And then if you ask it a follow-up question, it remembers which property is being talked about, which is why we need the memory. And then the tool we're going to use is going to be the Tailwind Search tool, which is a web search tool. So the code that LangGraph already gives you has tools built into it, which is the Tailwind search results, perfect for us. It also creates the model, which is a chat OpenAI model. Make sure that you have your OpenAI keys already added to it so you can call the model. And then finally, we're going to give a memory saver, a new instance of a memory saver, which is how LangGraph helps to create memory, short-term and long-term memory. And then finally, we can just create an agent by calling the function called createReactAgent. Cool. Now that the agent is here, you see in the example, they've asked it a question like, what is the current weather in SF? And then printed out the statements. Let's go ahead and delete this so we have a clean slate and use this agent. So what do we want to do? First of all, we know the question that the user has asked because it's here, and we know the properties. So let's create a question in the form of a human message. And why we're saying human message is because it helps to generate English language sentences. We're going to pass in the user question and stringify the property so we can create a question. Next, we're going to invoke the agent, pass the question in as a message, and then provide a configurable. What does this configurable do? This is actually how we assign a thread ID or provide context to the agent about which property is being talked about. So here we're going to provide the property.zip ID, the unique ID of the property address. And this way, the agent knows if we're talking about one address, then we have to keep answering questions about that address if the zip ID is the same, or the Zillow property ID is the same. And now that we have the agent next state, we just need to return the message. And in order to console log that message, I could just get the agent next state dot messages property and get the content out of the last message. And then we can just return this to give back the content that the agent has generated. So let's add const result. And now let's test this. So if I call real estate agent with a user question, let's give it a question of walk score of this property. And then I'm going to give it a property of, let's try giving a random property. Let's try this one, 4501 Southwest Dakota Street. Fix the format of this. Let's test this by moving this const result equals this, and then returning this result. Return result. Perfect. Alrighty. Now let's test this. We're gonna do real estate agent. We're gonna call this, and then it's gonna say, what is the walk score of this property with a property of Let's give it an address. 4501 Southwest Dakota Street, Seattle. With a, remember we need to give a Zillow PID as well. And let's give that. Now let's give it a shot. Let's try it out. Now if I do npx ts agent.ts, let's see what we get back. Okay, so it says the walk score of this property is 0.79. Perfect. So it did a web search for us. It was able to bring back the walk score of this property. This walk score is pretty low, so it's not a very walkable area. We could also ask it something more generic, like what is this a safe area to live in? And then if you test this, let's see what it gave back. Alrighty, so it says a bunch of things. But it says based on the search results, here is some information about this. Seattle has a violent crime rate of 6.8 per 1,000 residents. Oh shit. And a property crime rate of 52.3 per 1,000. Crime doesn't happen uniformly, so it's essential to consider specific neighborhoods. The crime rate provides crime maps, blah, blah, blah. So basically, it's giving you more information about this particular property, Southwest Dakota Street. It does say if you want more specific information, you may want to explore the crime maps and statistics provided by the Seattle Police Department. So, web search tool does its job, not accurate, not super specific, but it does its job. Or actually, let's ask it more specific question, like what is the appreciation rate of this property? Let's try that. This street, based on this, Seattle hasn't appreciated over time. To determine the exact appreciation rate, you can use home appreciation calculator, and here are some resources. Perfect. So it gives you more information on what to do by zip code and stuff. So of course it's not super specific because it's a more generic web search tool, but it gives you more details on how to find specific answers related to your questions. So it's super helpful. Now let's improve the UI interface so we can add a chatbot. So let's get rid of this. And I will add a new component called Chatbot component. So we created the real estate agent. It's ready to accept a user, a question, and a property. Now all we gotta do is expose an endpoint for it and then create a front-end component that actually calls that endpoint. So in order to expose an endpoint, I'm gonna go to my api.js and I've added an endpoint here called API/real estate agent. Here, all I gotta do is extract the question out of the request.body and then call the real estate agent. Then whatever response I get back, I'm going to send that back over to my front end. Now, the only part that's remaining is that I need to create a front end component that calls this real estate agent. In order to do this, I have created two helper components called Chatbot, which actually expects a messages array, and an onSend message, which expects a callback that understands what to do when a message is sent. And then I'm going to consume this chatbot in my component called real estate agent. Here, chatbot. So the main important part here is that anytime a new message is added in this chatbot, I add that to the chat history. I keep pushing that message with the role of user because the user is sending that message. And it'll just help us to create a nice little UI. Then finally, we need an onSend message, a handle send message, which understands. Let's go ahead and create that. So this is what the handle send message does. Anytime we've added a message in our chat, we're going to push that in our set chat history. We're going to push that message to the array with the role of user that helps to let our UI know that this is a text message sent by the user. Then we're going to set our loading to true so that we can show a little ... when the message is being retrieved back from the agent. And this is where we're going to call our agent endpoint. It's super simple. We're just going to call the endpoint with a fetch, and then we're going to send in our user question with the message and then the property address. And then whatever we get back, we're going to put that back in our chat history as the message that comes back from the agent. And that just helps us determine what is coming back from user versus what is coming back from agent. Now, this looks like a lot of code, so I've linked the GitHub repo in the description. Check it out. It looks like a lot of code, but I promise you it is super simple. So now if we've done everything right, we should be able to talk to our agent. So let's try this again. Okay, let's try an example search. 600,000 to 900,000, looking for a 3-bedroom house, and hit search. Okay, we're thinking about it and we did it. Okay, so we've got some houses, 789, 850, and we see this real estate agent at the bottom. So if I click this, before I click this, I'm going to click this question, ask a question, and I wired this up with the help of Zustand such that when I click on ask a question, I also update my Zustand store so that I am storing which property I'm talking about. And that is how I know what is the value of the property.street address. So if you look here, this is where it's coming from. We've got it coming from agent store, which is actually a Zustand store. If you want to know how we created that store, I'm going to link the live stream right here so you can check it out. I develop most of these applications on live streams. So if you're wondering how I built this, come and join me on my next live stream. It is going to be on YouTube, and all you got to go do is click like, subscribe, hit that bell icon so you get notified of the next live stream. But now let's try this agent again. So I'm going to ask it, which property address did I select? 112 North 80th Street. Okay, let's try like a different property. I'm going to click this property. And also I showed you a little sneak peek of what we're going to do next, but we're going to try a question here. I have a question about this property. How much, let's try this. How far is it from restaurants? Oh my God, real estate agent encountered an error. Wouldn't be a demo without an error, would it? Okay, let's see what's the error. Server responded with 404. That's because I did not run my server. So let's go ahead and run this. Oh wait, no. Handle send message. It's because it's getting 404 because the API endpoint probably doesn't exist. Real estate agent. Okay, I'm gonna make sure that my API is running properly. I've got this running. I've got the front end running, but I don't have the back end running. Oh no, I have the back end running, but I don't have my Convex running. So run my Convex. Alrighty. I'm going to make sure that my real estate, I'm going to restart my server as well. Cool. Now give this a reload. Try an example search, hit search. Error's gone, all right. Actually, some errors still exist. Fail to parse this. Okay, we'll take a look at that in a second, but how's my agent doing? Let's ask it, what is this area like? Okay, now we have a 500 error. And we have an error because... Oh, okay, we are missing a thread ID. Let's go ahead and find this. All I had to do was fix the property Zillow PID because I missed this. And now when I go ask what is this area like, it gives me back this information. The property at this address is a single family home with this, currently listed for this much. The house was built in 1942 and spans this. Now you can ask it some generic questions like, what is the school district like? And so it can say, this serves the area with the property is located. You can find more information about Seattle Public School Districts here. You can contact them at John Stanford Center for Educational Excellence. So let's see if I say how many restaurants are close to this. It says, okay, there are several restaurants near this. Here are some resources. Restaurants near this. You can check out these resources to find out more information. Nice. And if I say which restaurants are open now, let's see how detailed it can get. It says here are some restaurants that are open now near 4501 Southwest Dakota Street. Perfect. Now I have not verified to see if this is correct, but at least it's giving me some information that is good enough to get started. So that's the thing about agents right now with one single tool such as web tool with the help of building a create React agent from LangGraph. We can give it multiple tools and configure how we use the tools to make it more specific. One of the things that I didn't do is retry the agent. So what happens is if I get a wrong message or if I get a wrong info, which sometimes I've seen when I have asked it for things like walk score, it doesn't understand that it should verify what it's talking about. So in order to do that, we could create better agents with the help of Convex Agent Store, with the help of Convex agents, which is going to be part of the next video. So stay tuned for that. And if you've made it so far in this video, comment pink door in the video so I know that you're part of my OG tribe. And also other people will be like, what the hell are they talking about? What pink door? So comment pink door in the comment to let me know that you watched this segment. And now for the final part, let's get the part done where we show you similar properties you may like. So we talked about how to create embeddings for a property earlier in this video. In order to perform a vector search, Convex gives you a handy function called ctx.vectorSearch. And now I'm going to give you a hint so you can do this on your own. Basically, in order to create a recommendation engine, we need to compare two properties and ensure that their embeddings are close enough. In order to do that, Convex gives us this function called convex.vectorSearch, which can actually search a table by the embedding that we've stored in the table. Convex makes it super easy to do a vector search by just this function. And in order to do that, we just got to give it some fields that we want to test against and the vector where it is stored. Now, here's the homework for you. I want you to try out this vector search and let me know which field you're going to use to create a vector search against. So I want you to do this function context.vectorSearch and tell me what is going to be your similarity index. So filter fields basically means these are the things that we're going to search similarity for. So we want a property to be similar in preference, which is we've liked it, similar in price, as in shouldn't be too far from our budget, should be similar number of bedrooms, not too small, not too big of a house, bathroom, street address, and so on. And I want you to tell me for your vector search, what is your field gonna be? So try this out, give it a go. All of the code is gonna be linked in the repo if you get lost. The only thing remaining from here after doing this vector search is actually to consume these results. What the vector search is going to give you back is an array of embeddings and is an array of properties that are similar to the one that you've given. But it's going to give you an ID from the database. And all you've got to do is query the database, get that ID out, and you're good to go. And with that, you'll be able to create similar properties in this area. So give that a shot. Let me know how it goes. So if you followed this video so far, you've learned how to generate an embedding using OpenAI, store that embedding within a vector database, which is Convex, and then create an agent using OpenAI and LangGraph. And finally, tie that all together so that when we create a UI, when we search for a property using plain English language, we're able to convert that from English language to JSON, which then calls our real estate API, the Zillow API, which gives us back a bunch of properties, which we display on the UI. We've added like buttons and dislike buttons, and we've added an ask a question button, which then pops up our agent. The agent is an AI real estate agent, which uses OpenAI and Convex. And finally, when you've clicked on ask a question, we also show you other properties you might be interested in. I hope this was useful for you. If it was, let me know in the comments. Also, if you like this video, you gotta hit that like button and subscribe. It really helps my channel grow and helps me feel happy. So thank you so much for watching this video. I will see you in the next one. Bye.